Now, we need to find the product of Fi and Ui, that is, Fi into Ui for each class interval. Consider class interval 10 to 25, where Fi equals 2, and Ui equals -2. Then Fi Ui equals 2 into -2. This is equal to -4. Consider class interval 25 to 40, where Fi equals 3, and Ui equals -1. Then Fi Ui equals 3 into -1. This is equal to -3. Consider class interval 40 to 55, where Fi equals 7, and Ui equals 0. Then Fi Ui equals 7 into 0. This is equal to 0. Consider class interval 55 to 70, where Fi equals 6, and Ui equals 1. Then Fi Ui equals 6 into 1. This is equal to 6. Consider class interval 70 to 85, where Fi equals 6, and Ui equals 2. Then Fi Ui equals 6 into 2. This is equal to 12. Consider class interval 85 to 100, where Fi equals 6, and Ui equals 3. Then Fi Ui equals 6 into 3. This is equal to 18. Now find sigma Fi and sigma Fi Ui. Sigma Fi is the sum of all the frequencies, that is, sigma Fi equals 2 plus 3 plus 7 plus 6 plus 6 plus 6. This is equal to 30. Sigma Fi Ui is the sum of the values of product of Fi and Ui, that is, sigma Fi Ui equals -4 plus, -3, plus 0 plus 6 plus 12 plus 18. This is equal to 29. Then, the main x bar is equal to equals a plus h into, sigma Fi Ui by sigma Fi. Now, substituting the values of a equals 47.5, h equals 15, sigma Fi Ui equals 29, and sigma Fi equals 30, we have x bar equals 47.5 plus 15 into 29 by 30 equals 47.5 plus 14.5 equals 62. Therefore, the mean of the marks obtained by the students is 62. Note: the mean obtained by all three methods, direct method, assumed mean method, step deviation method, are the same. The assumed mean method and step deviation methods are simplified methods of the direct method. The step deviation method is applied for all, which has di common factor. The formula x bar equals a plus product of h and u bar, or ui equals xi minus a by h. Let us see the remarks. Choice of the method. Choice of the method to be used depends upon the numerical values of xi and fi. For example, if the values of xi and fi are numerically small in numbers, then we go for direct method. Or, if xi and fi are numerically large numbers, then we go for assumed mean method, or step deviation method. Or, if xi and fi are numerically large numbers, and class sizes are unequal, then we go for step deviation method. Let us see another example. The table below gives the percentage distribution of female teachers in the primary schools of rural areas of various states and union territories, UT, of India. Find the mean percentage of female teachers by all the three methods discussed in this session. Please note that, if the given example class interval sizes are equal, then we can apply all three methods. Let us see the solution. In order to find the mean of the given data, let us first find the class marks for all the class intervals. So, let us consider the interval 15 to 25. Here, lower class limit is 15, and upper class limit is 25. As we know that, class mark is calculated as lower class limit plus upper class limit by 2. This is equal to 15 plus 25 by 2. This is equal to 40 by 2. This is equal to 20. Therefore, the class mark is 20. Similarly, we can find the class marks for remaining class intervals. Let us consider the class interval 25 to 35. Here, lower class limit is 25, and upper class limit is 35. Since Class mark equals lower class limit plus upper class limit by 2. This is equal to 25 plus 35 by 2. This is equal to 60 by 2. This is equal to 30. Therefore class mark is 30. Consider the class interval 35 to 45. Here, lower class limit is 35, and upper class limit is 45. Class mark equals lower class limit plus upper class limit by 2. This is equal to 35 plus 45 by 2. This is equal to 80 by 2. This is equal to 40. Therefore, the class mark is 40. Consider the class interval 45 to 55. Here, lower class limit is 45, and upper class limit is 55. Class mark equals lower class limit plus upper class limit is divided by 2. This is equal to 45 plus 55 by 2. This is equal to 100 by 2. This is equal to 50. Therefore the class mark is 50. Consider the class interval 55 to 65. Here lower class limit is 55 and upper class limit is 65. Class mark equals lower class limit plus upper class limit is divided by 2. This is equal to 55 plus 65 by 2. This is equal to 120 by 2. This is equal to 60. Therefore, the class mark is 60. Consider the class interval is 65 to 75. Here, lower class limit is 65, and upper class limit is 75. Class mark equals lower class limit plus upper class limit is divided by 2. This is equal to 65 plus 75 by 2. This is equal to 140 by 2. This is equal to 70. Therefore, the class mark is 70. Consider the class interval is 75 to 85. Here, lower class limit is 75, and upper class limit is 85. Class mark equals lower class limit plus upper class limit is divided by 2. This is equal to 75 plus 85 by 2. This is equal to 160 by 2. This is equal to 80. Therefore, the class mark is 80. Please note that this calculation of class mark can be found by the shortcut method also. That is, as the class size is same for all the class intervals, we can get the class mark by adding the class size to the previously found class mark.